All right, let's talk about some decomposition reactions. I have 4 reactants here. I have iron 3 sulfide, aluminum chloride, sodium carbonate, and magnesium chlorate. So first let's look at iron 3 sulfide. When that breaks down, it's going to form iron and sulfur. Now, since there's nothing special about iron 3 sulfide and neither of those two elements are diatomics, then I can just write down the elements. Now, you look at that and you think, you need to balance this thing. A lot of kids, they want to put 2 down here, a 3 there. You just carry those subscripts over to the other side. You can't do that, all right? When you put that little 2 there, you put that little 3 there, that's saying that 2 iron atoms are traveling around as a little iron molecule. And iron doesn't do that. Same thing with sulfur. It doesn't travel around in little 3 atom molecules. It will travel around independently. So we're going to erase this. And in order to balance it, we're going to add coefficients. So we will put a 2 there and a 3 there, and now that equation is balanced. Aluminum chloride. When it decomposes, similar to the last one, you're going to make aluminum and chlorine. However, when chlorine is alone as an element, it's a diatomic gas. So I'm not going to just write Cl, I'm going to write Cl2. Why do I write that 2? Because chlorine's one of a few elements that travels around in pairs. So chlorine, bromine, iodine, nitrogen, oxygen, fluorine, hydrogen. So those 7 travel around in pairs. So they are the diatomic elements. So that's why that little 2's on chlorine. And now I've got 3 chlorines on this side and 2 chlorines on that side. So it's in need of some balancing. Here's my thought process. 3 and 2, the least common multiple of 3 and 2 is 6. So I'm going to put a 3 on the chlorine. I'm going to put a 2 on the aluminum chloride. That leaves me with 2 aluminum atoms. And so I'm going to put a 2 there to balance that out. Next up, we have sodium carbonate. Carbonates are a special class. When carbonates decompose, they aren't going to split into each constituent element. Carbonates will produce carbon dioxide gas and then the metal bonded to oxygens. So we're going to decompose this. It's going to make CO2 plus, and then sodium. So sodium forms a +1 ion. Oxygen forms a 2- ion. So it's going to be Na2O, sodium oxide. And lo and behold, that comes out balanced, so I don't have to do any balancing. It's already taken care of. And lastly, we have magnesium chlorate. Chlorate, like carbonate, will decompose into something a little bit special. It'll form a metal chloride, so this metal will go with the chlorines there as an ion, so it'll be chlorides, and oxygen will be liberated. So chlorates break down, they make oxygen and a metallic chloride. So we're going to form O. Now, oxygen is also one of our diatomics, like chlorine was. So I'm not going to write just O, I'm going to write O2. Plus, magnesium takes on a 2+ charge, chlorine takes on a 1- charge, so that means the formula for magnesium chloride is MgCl2. And now that did not come out to be balanced. So we've got 1 magnesium, 2 chlorates, so that'd be 2 chlorines, so that's actually okay. So 2 sets of 3 oxygen, that's 6 oxygens. So I'm going to put a 3 on our O2, and that should 6, 2, yep, and that balances it. So there are a couple decomposition reactions similar to what we've been working on in class.